So today we have a very interesting guest and a pretty relevant topic for discussion. And the topic is going to be around trust nothing, verify everything, and how do we how do we manage risk in this new digital economy? I have here Chris Smith, who has a fascinating background, which I will let him introduce in a second. But I'm Hari, one of the founders of Cantina. I used to work at the Ethereum Foundation before this, building the Solidity language. And one of the things that we noticed pretty early on is security in crypto is very important, where every single line is important. And if you make a single line of mistake, unfortunately, there's like billions of dollars on the line. So we built a company around solving some of the security challenges in this new crypto Web3 economy. And we have been doing this sessions with various security experts from around the world with a lot of different backgrounds, and to hear their practical advice on how to manage risks and security broadly. So with all of that said, let me hand it over to Chris Smith. Do you want to do an introduction of yourself, particularly on your background building a billion-dollar protocol?
Sure. Thanks, Hari. Hello, everyone. So as Hari said, my name's Chris. I have been in and around the Ethereum Solidity landscape for many years. I got started in late 2017 learning smart contract and Solidity development back before we had proper debugging tools and test chains to work with that were easy to manage and everything. I worked at Consensus out of the gate at one of their spokes, focusing on what we now call RWAs, fractional real estate tokens, at that instance, and had a really good exposure to one of the lead auditing entities at the time, early on, Consensus Diligence. And that kind of started to ingrain the idea of what Hari is talking about, how one line of code can really cause a lot of damage to your product, to your company in this environment. From there, I worked at Maker Foundation. I was part of the smart contracts team looking at how do we launch multi-collateral DAI securely. I was on the other side of the audits at the time and the bug bounty programs at the time, trying to make sure that we had done proper threat assessments and security analyses, and that all of the code was ready and everyone on the team was ready to launch from single collateral DAI into multi-collateral DAI. Continue to work in the space later at MakerDAO as part of the protocol engineering team, which was the smart contracts team that worked for the decentralized entity responsible for building new features, as well as the regular spell cadence, which is how we would push updates into the system. Again, throughout all of those experiences, very security focused, understanding as a team and as a culture that you really can only get one, or can't get a single thing wrong in this environment. Otherwise, especially once we're dealing with launched multi-collateral DAI, we're operating in an environment where there's billions of dollars of value on the line. If we make a mistake that exposes the protocol to a security risk or simply locks the protocol, we could lose that value and we can't recover it. So ingrained that security perspective even deeper. And then after MakerDAO, I worked independently as a security researcher, and then obviously joined Spearbit as one of the lead security researchers in their fellowship over the last year or two. So that's maybe not quite as short as I would have liked, but that's my background kind of leading into this conversation.
Yeah, I think for those listening, Maker, from my point of view, is one of the pioneering protocols in crypto itself. I think, and one of the things that Maker pioneered, along with Maker pioneered multiple things, but one important thing is security. I've never met a team that was so ahead of its time when it came to security, like the Maker team. They were obsessed about security, and they understood that if you have to grow this decentralized protocol to billions of dollars, you have to invest into security very early. And unfortunately, a lot of teams make that realization quite late into the process, and by that time, there's often like an incident that is make or break for the company. So Maker, one of the a pioneering team when it came to like engineering and also like security itself. So Maker, the team behind Maker built a lot of the early tools that Chris mentioned. Like he was building smart contracts at a time where the tools that are available today did not exist, and some of the early tools were pioneered by the Maker engineering team. So a phenomenal team, and I think you learn a lot by being in that environment, and also like having to manage billions of dollars. That's a entirely different story. So let's start with the first topic, which is, how did we move from like the Web one, like, so to speak, to Web two to crypto? And I think Chris already alluded to this a couple of times, managing billions of dollars securely with upgrades is a big challenge. But can you like, take a step back and talk about like the environment? Why like Web two is different from crypto, and what did you learn at Maker and other places that made you realize that?
Yeah, for sure, Hari. So you are absolutely right, and I was very much the beneficiary of getting to join the Maker team and follow in the footsteps of those people who made the DApp Hub people who were building those first tools and really instilling deeply in the culture of Maker, and thus I got to kind of absorb that myself, that security first perspective. I think the simple way to answer your question about what's the difference between Web one, Web two, and what we have in Web three right now, especially as it relates to security, is when we talk about cybersecurity, we're fundamentally talking about securing information. And in Web 2, that means customer information. That might mean access to your system. That might mean proprietary business information, which have an indirect correlation to money and value to your business or to your organization. In Web3, information is the value. It is directly correlated to the money. So when you steal information from a Web3 company, likely you're stealing Ether, or you're stealing DAI, or you're stealing whatever token that company is producing as the information. So the stakes in Web3 when it comes to cybersecurity or comes to security in general, I'm not by training a cybersecurity expert. So when it comes to security, it is about securing, it's the same question. How do we secure the information? How do we secure the thing that our technology team is producing? But in this case, that information is the value, and we've tied those. That's the definition in my mind of kind of what Web3 introduces that's different from Web2. And that means that the stakes are a lot higher when it comes to security.
That's a beautiful way to put it. I think I'm gonna steal that. Like the value itself is the money. And I think you alluded to this as well. Like one interesting difference between the Web 2 and the crypto on how to build software is also has to do with control, like how much control you have on the underlying value itself. In case of a bank, if you have a cybersecurity incident, even if you manage to send $1 billion to a different bank or a different account somewhere, it's somewhat of a reversible process, assuming that you can figure out, you lost money. Unfortunately,
Mhm.
in crypto, the reversibility is not really possible in most cases, and that's part of I think that's part of the problem. And do you want to talk a bit about how control and ownership and composability work in the context of crypto and why that makes security much more challenging?
Yeah, absolutely. So I think that's an kind of gets to another core fundamental difference between Web 2 and Web 3. When I build a web application in Web 2, if I'm building an API for other companies to interact with, most likely I have a very distinctive outer edge of that API. I'm going to institute some sort of off check on those edges, and then everything else kind of is internal to my program. Someone would have to have access to my system in order to affect the internal calls or to affect the database or something if things are built correctly. With Web3, those edges are much more porous in the sense that all of our APIs, all of our smart contracts are deployed on a public computer that anyone can access when we're talking about Ethereum, unless we're talking about a private chain, which is a different sort of idea. But in Ethereum and DeFi, all of those edges are public. And one of the first security talks I went to and had a researcher who was talking about this idea of every connection between your smart contracts, every function call is a red line. It's an edge of your system that you need to secure. You need to make sure that every single one of those is secure, as opposed to in Web 2, maybe only the outer edge. That candy coating needs to be non-porous and everything inside can be a little bit more lax. So that's one difference, I think. The other difference is that in Web 2, we classically have companies like early Facebook that whose slogan is move fast and break things. We can't do that in Web3. When you break things, as Hari says, it's irreversible. You can't go back and get the money back. You can't recover that information. You can't just have everyone change their password and put things back to normal in most cases. In Web3, there are patterns that we can use to have upgradability where we can affect the code that's live. They're very challenging patterns to get right. And I think that they often introduce other security considerations and allow teams to make business decisions that weaken their security stance because they don't have to be as set about the code that they're launching. So I tend to try to think about the code that's going to go live as you can choose one of these two analogies of the common ones that I hear is I'm deploying code to a satellite or I'm deploying code to an ATM machine. I don't have access to that deployment location anymore to change stuff. If I've launched my satellite into space, I'm not going to go just plug into a port and update the software. I can't patch it. So it needs to be perfect. And in a lot of ways, I think thinking about Solidity code in the same way that we think about how NASA developed the space program and the secure mechanisms that we have when we see engineering with spaceships or planes or those sorts of mechanisms is maybe a better analogy than say early days Facebook, where it was really just, get it to work, patch it, get it out there live. Whoever gets out there first wins. There's a much stronger tension in the Web3 space where, yes, you have to get the product out there. You have to be early enough to capture market share from a business perspective. But if it's not secure once it's out there, none of that matters because you're going to get hacked and that will hurt your company and your reputation way more than being late or being slow.
I also love the rocket launch example. Um, but I would say it's probably like one step further because there is a lot of malicious actors trying to sabotage you all the time. So it's almost like you're trying to launch a rocket, but at the same time, other people are trying to like launch rockets at you. So it's an even worse environment where if you can thrive in this environment, you can thrive anywhere. But
Mhm.
it's a very intense environment where everyone is trying to, because the stakes are very high, people are trying to, steal your money at the end of the day. So it's a extremely challenging environment, but if we can, make it work, it's the rewards are like incredible. Like you can have a very small team build all protocols, which are unheard of in the Web2 world. And if you have
Mhm.
for a bank that custodies like $1 billion in assets, and you're talking about a massive team, a lot of software, whereas in Solidity, this could be like few hundred lines of code, and you can ship this very safely if you know what you're doing. So the rewards are worth it, but there is some risk.
Yeah, I think that's the other side of kind of the coin that you talk about of these transactions are irreversible. Once it's out there, you can't take it back. You can't turn it back. But the other side of that is that we can build software that relies on that fact that once something has happened, I don't need a whole compliance department or checks and balances and secondary communication with the other bank to make sure that the money's actually there, or waiting 3 days for settlements or 30 days in the case 30 60 days in the case of a credit card for all the mechanisms to be in place. Once it's there, it's there, and that's allows us to unlock certain features that we can build in Web 3 that we can't build in Web 2, but it comes with the security risk of finality. Once it's gone, it's gone.
Yes. Um, the next topic I want to talk about, which again we spoke about it briefly at the beginning, which is I think Maker did a phenomenal job having this security first culture. Can you talk a bit more about, why that is the right way to build software in crypto and why you can't necessarily bolt on security towards the end? Why do you have to think about security from day one? Let's maybe like dive deeper into that. I think you also mentioned the basic example, which is great. It's a very different cultural building. And why doesn't, can we dive deeper into why that doesn't really work in crypto? And what are some lessons from the maker culture that that other people listening can take away?
Yeah. So I think we've hit on a lot of those topics already. To try to bring them together, finality is obviously the kind of the big headline there. Once you launch your product and you have value, if something happens, you can't take it back. There's no undo. There's no patch the server in kind of traditional case or sense. Um, you said it, Hari, as well about my satellite analogy. It's not exactly accurate because it's such an adversarial environment. You don't have access to your software, but everyone else does. And they get to do whatever they can do with that software. I don't know how popular it is now in the space, but there was kind of an old meme of code is law. If you launch a smart contract that says I can do something, even if it wasn't what you intended, that's what the code says, so I can do that. And I think that largely legal systems around the world say that's not the case. But at the end of the day, we're not all operating within the same legal system, and these smart contracts, these programs that we're launching, operate in such a multinational environment that if you write one where someone can take the value out, then they can probably get away with that. Um, Certain actors certainly can get away with that. I think the other thing to think about is two things. Ingraining security in your team culture early on will mean that it is a first-class citizen within the organization, not just from the smart contract perspective, but also from the team culture, internal OPSEC perspective. So one of the two common hacks that I hear about these days are kind of the job applicant hack, where multinational actors are basically seeding candidates into job interviews who are there either to infect the interviewers or to even kind of long run get embedded in the team so that they can slowly work in bugs and problems into the code. And that could be web 2 code that interacts with the web 3 aspects. And so that's one risk. Another risk is actually what we're doing right now with Zoom. If Zoom has that feature of when you join a Zoom link, it immediately starts to try to download something. And most people got used to, especially during the pandemic, simply saying, yeah, I'll download that. I'm going to launch Zoom. I've heard about attacks where it'll be a fake Zoom link that looks right. It'll download malicious software. And then, oh, the audio doesn't work or the video is not working. I need you to do this thing. We reset our driver, just run these commands, and it installs malicious software. And now your computer is compromised. And if your computer or your dev's computer is compromised, then you can't really trust the output. So early on, you could be infected even before your protocol is hacked if you're targeted. Or as we saw with a large exchange recently, whose name is escaping me, you could be targeted in the sense that the web interface that you use gets infected upstream of you, or your NPM packages are infected upstream. So there are a lot of considerations. I read a tweet recently about someone who had installed a malicious cursor extension. And in case you didn't know it, everything that you type into VS Code or cursor is being sent via API calls that may or may not be secure to many different places. Certainly VS Code, certainly Cursor is sending them to the AI agents that you're connected to. And then any extensions that you use are probably sending them back to their backend servers. So your coding environment, if you just happen to need like a blank space to copy and paste a private key, that private key I would consider compromised at that point in time. So sorry, getting a little bit into the weeds there, but like having the security culture from the beginning, I think is very, very important. There is going to be, and I alluded to this already, there's going to be a tension between getting product out and building it correctly. And I have seen that tension play out much more poignantly in Web3 than in Web2, because again, in Web2, we can go back and fix things. And in Web3, that needs to be a much stronger balance. And so I think the teams that I've seen be most successful in the space are ones that have the culture where everyone from the CEO all the way down to the biz dev salespeople are not comfortable launching something unless we're all reasonably convinced that we have done everything we can to secure it. And the teams that I've seen with some of the riskiest kind of code that they think is ready to go live are the ones that have the highest pressure to get something out and to capture the market or to meet a business deadline. Going back to my experience at Maker, I was fortunate when I joined the foundation, they had already instilled that culture, and going live on MCD was not a question of what did we promise, what did we put into a press release, what did we say on our Twitter account. It was a question of, does engineering say that we're ready? Have we run our 3 audits? Have we run our bug bounty program on testnet even before we're live? And until those questions were answered, we didn't commit to a deadline. And it kind of became a meme within the culture of like, we're going to launch soon, because no one knew what soon meant, because we couldn't tell you when it would be secure enough and we'd be ready enough. And so, yeah, from start to finish, I think you do yourself a real service if before you even start writing code, you orient the organization decision making around, we're not launching until this code is secure and ready. And what does that look like for us? Not we've committed to this, or we need to capture the bull market, or prices are going up, we need to get out there, or whatever.
Those are some like, real examples that you rarely hear from other industries. Like there's the reality of like, building a real product with billions of dollars on the line. And you have to make these trade-offs. And I think security is like one interesting trade-off. And in the Web2 world, you can often trade it off with velocity, but in crypto, not as much. One thing I want to particularly highlight is, there is this idea among people that, hey, I can build a private blockchain, or I can build a token with blacklisting. For example, USDC has some way to blacklist. Um, but if you want very instant interoperability and composability with other systems, then again, this is like an environment where somebody can steal money, but instantly like cash out in the same transaction or block to something that they cannot be censored. So this is also something that, often people think, oh, they're safe because USDC has ways to blacklist things, but it's still vulnerable because they will, if an attacker can get hold of USDC in general, they can instantly like swap it to Ethereum or Bitcoin, which you cannot really censor at that point. So something to keep in mind, where in the
Mhm.
system, even if your control environment has like guardrails, if there is a way to get out of the system instantly and it's final, then
Mhm.
attackers can still steal that money. So it's not just safe if you have a blockchain that's like fully KYC, if people can easily like move things out. The next topic I want to cover, which also came up in some questions from Andy, is what are some of the real world examples of security bugs?
Mhm.
Maybe I can like answer the first question second question by Andy, which is based on Cantina's work, what's the most common bugs that institutions should look into? It's a great question. And I would say like a lot of the bugs that we see are logic bugs and business logic. Um, so, you are supposed to do X, Y, and Z, but you're actually not doing that. In the Web2 world, again, this is not something typically exploitable. Hey, you're doing something and it's not exactly doing that. It's oftentimes not a big deal in the Web2 world, but unfortunately in crypto, a lot of these mistakes can be exploitable. For example, if an admin cannot access, if a function can only be called by an admin and it can be called by anyone in the Web2 world, like the risk is not too high. Obviously, like there are risks, but in the crypto world, like oftentimes that is a way to steal money. So really obsess over business logic bugs because it's something that is often overlooked in the Web 2 world because you can always patch it. Um, so that's like the number one thing that I would ask your team to pay attention to. But the second thing that is quite important these days is the social engineering attacks. It's very prevalent. It's becoming more and more cheap to do, and we're seeing like industrial scale social engineering attacks these days. I think Chris brought up a great example with parser. So every system has the scale. They have to invest in trust and safety mechanisms. So if you are VS Code, which is a product by Microsoft, that this trajectory where it started at zero, and next month maybe like 100 users, and then over time it's like increase like in a gradual way. Whereas these products like Parser, we're not talking about getting million users in like 1 month, 2 months. And oftentimes what happens is your team is not prepared for the real adversarial environment because you have this rapid growth in like 2 months. So what often happens in the systems are on VS Code, this wouldn't be a problem. Where if I put out a malicious extension, like Microsoft has some way to flag that, hey, this is bad. But whereas these new systems, their team is not really prepared to do that threat hunting out there. And unfortunately, like these attackers abuse this gap in like abilities by posting something that wouldn't work out in the Microsoft version of VS Code, but it would work out in the Cursor version because their team is not as mature. So watch out for like I think the number one thing to watch out for is like if you're using software that's not necessarily mature, now there are gaps and you need to be ready for that. Chris, what's your
I
take?
would Yeah, no, absolutely. And I would even take it one step further. I think even mature software, and VS Code's a good example on one side where, yeah, Microsoft runs VS Code. They're probably pretty secure. I'm not that concerned about Microsoft or the fact that it's sending it up to GitHub Copilot. I don't love it, but maybe from a security standpoint, it's not my top priority. Any extension that you add to VS Code is not coming from Microsoft, and I wouldn't trust that they have a robust security evaluation of those extensions that you're pulling from the VS Code marketplace. So even mature software like VS Code can be made less secure by your users' actions. One step further, something that really I think is I've seen get talked about more and more about in the space, but is still not talked about enough is supply chain attacks. So you might be working with a really mature piece of software, and then under the hood, that's installing an npm package, which is installing an npm package, which is installing an npm package, and that fourth generation back of npm packages is run as an open source project by one contributor that's been running it for free for 5 years, and they're not in crypto. They're not paying attention to crypto security vulnerabilities or concerns. They get targeted. That package gets taken over. And now the attacker has a direct line into all of those subsequent packages that inherit that one. Or we've seen where people will come in and decide to pay that individual contributor, hey, you've been doing a great service for the community. We'll give you $100,000 because their package is used by web wallets or it's used by common Web3 interfaces. And so they know that by getting access to that package, they can start to inject malicious software or take money or take data back out of the Web3 industry way upstream. And so being really careful about not just the smart contract aspect, but how are you interacting with the smart contracts and what software protections do you have? Are you locking your packages to known secure package versions? When do you upgrade those? Those are kind of Web 2 type security practices that become a lot more consequential in Web 3.
Yeah, totally. I think one way to think about security in general, especially when you're dealing with billions of dollars, is you have to assume that individual people will be compromised, but you still need to build a system where with one or multiple people getting compromised, you have to minimize the risk. So you have to assume that you know potentially a developer in your company will be compromised, but even then, they shouldn't be able to steal billions of dollars of value. What Chris mentioned, like paying people money, like this is like real. Like there are instances where I think this is what happened with one of the Coinbase phishing attack, where you know some of their some of their support staff in overseas, they were paid money by these attackers to access information. So it's very real, and you still have to build systems assuming that people will get compromised. People might become malicious themselves, and your system has to still function properly. So there needs to be a lot of guardrails. There needs to be maybe like even investments into insider threats, because that's something that we're seeing quite often for large institutional companies. Like even even something like Twitter, like a lot of the security bots that we see are people getting compromised inside Twitter, either as support staff or paying people off to get access to accounts that they're not supposed to get access to. So assume that people will be compromised, but you need to still build a system where it's like resilient. What could happen if one of your developers are compromised? Can they steal $1 billion? So I think that's a very valid question to ask if you are, building a system.
I think that is another way that I would answer Andy's question. So, based on the reviews that I've been doing, what is a vulnerability institution should look into? I don't. I would not write a finding in a review that says this function is controlled by an admin address and it can drain the entire protocol, because that's likely how they designed the system. And that trust assumption is not from a from a smart contract security review perspective, that is not a vulnerability. But we're not looking into the control mechanisms that they have for the private key for that address or how that's set. So if you've instituted, Hari mentioned this, if you've instituted a blacklist on your smart contract or upgradability or some other security feature where you're trying to build a stronger wall, likely that feature is controlled by some permissioned address. How is that address being protected? So when you look at other protocols, if you're an institution evaluating DeFi protocols, one of the key things that I would look into that isn't probably going to be strongly highlighted in the security review audit of their smart contracts is what is their permission scheme? How can someone take over that private key? So if you take Hari's assumption, which you probably should, that someone in the organization will eventually get compromised, can they get access to the private keys to take over the entire system because you've built in an admin backdoor effectively? And so looking at the security practice and kind of security maturity of the team around how do they protect their access to the system is something that I would strongly investigate. And that goes back to the question Hari asked about why you take security into consideration early on. If you can build a system with less protections, it is a more secure system. Sorry, with less permissions, it is a more secure system. The more permissions that you instill into the system, the more times you say, oh, well, we'll just have an admin control that, or we'll have a special permissioned actor control that. Those are all kind of holes in that security wall of what can the smart contract do.
Yeah. And to talk about some very real examples, what you notice is if your protocol gets big enough, there are these malicious actors that will try to poke holes in it, both on software and on people. So what we notice quite frequently is if you have a protocol that is managing $1 billion, whether in a permissioned or permissionless way, if you're trying to hire for new engineers, you will frequently notice that a lot of the applications you get are from North Korean IT workers. So this is something we hear all over and over from the teams we talk to, where they are pretty hot protocol, billions of dollars over the last 12 months, and they go try to hire new engineers. And turns out that maybe like 50, 60% of the applications that your recruiter is reviewing, they are North Korean hackers. And you need to protect yourself from these malicious people becoming insiders in your company. And I think the crypto culture historically has been very open to anonymous people that are building software. But I think this is something that is starting to break today because of all this new malicious threat actors. The same example as Cursor. I think it worked. It worked when it works when you have a small system, like you don't have to worry too much about trust and safety. But when you have too many people using your product, now there will be these malicious actors trying to come in and see, hey, can I get in somewhere? Can I be your employee? Can I develop a package and get through your system so other people can now download it? So I think these are problems that you have to worry about, and a lot of these problems also um, exist in the Web 2 world. In fact, there was a study that said there are more North Korean IT workers working in the Web 2 companies than in crypto companies, even though the the threats, no, well, even though the outcomes in crypto are far worse because now you can like steal money. But even then, there is a lot of North Korean IT workers working for Web 2 companies. Probably not the Facebook scale, but a lot of like smaller companies in the Web 2 world. So going back to your question, Andy, like in your experience, which parts of traditional financial risk framework translate well to Web3 and which one breaks completely? One of the things that I think the traditional financial risk framework does a good job is controls who has access to what, who can do what, and limiting the amount of access to only like a small set of people that really need to have that access. I think this is something that translates very well to crypto in some sense, like understanding who has control. And if I put my money into Maker, like who can actually like access that money? That is a very important question that I think both the Web 2 and the Web 3 people do a good job in. And the part that breaks completely is often, I would say, the business logic bugs. I had this conversation a while ago with I would say, a Web 2 exploit developer who works for like a for for a country, and one of the things he mentioned was in the Web 2 world when they try to develop these malicious, well, these exploits for their government. Um, Business logic bugs are not very interesting because you find flaws in their logic, but it's not really exploitable. But in crypto, it's often exploitable. You make small mistakes in how your logic is supposed to act, and now oftentimes you can convert that into a bug that would drain money. So traditionally, this is something that, in my opinion, is somewhat overlooked because people think you can patch it when you find it. So this is something that people need to pay more attention to. So the Web2 security frameworks often pay more attention to controls than the security of your software itself. So something to really think when you're building software in crypto. Any other take, Chris?
No, I think you covered it. I think within business logic attacks, I would add economic attacks. That's probably something that doesn't really exist in the same way in Web 2 as it does in Web 3. It's not just your economic mechanisms, but it's also any economic mechanism of a protocol that you're interacting with. In isolation, you need to understand their economic mechanisms. But now you have two economic systems that are interacting with each other. You also need to understand the economic system that's now formed by the interaction of those two things. DeFi is great because it gave us money Legos. But if I interact with a protocol that is also a public protocol that other people can interact with, I might miss security vulnerabilities or economic vulnerabilities in my system because the underlying protocol is vulnerable to them. Even if that vulnerability isn't a vulnerability for them, the way I'm using their system, it might become a vulnerability. So there's some interplay there when you're dealing with connected systems that are probably not well envisioned in traditional Web 2 risk assessments.
That's a great point. I think we frequently notice protocols where they themselves are safe in some way, but because they have a dependency to a different protocol, and because they sometimes upgrade the protocol, now they are vulnerable. So this is a very uncommon scenario in the Web2 world. And one of my favorite concepts to often explain to people, that come from the Web2 world about DeFi is this idea of a flash loan. It's such a, unique and crazy concept that
Yeah.
really like, blows your mind when you learn about it for the first time. So it's this idea that you can take a loan of oftentimes like infinite amount of dollars and then repay it back in the same block. It's a
Mhm.
very obscure idea, but this is like often like a precursor to many economic attacks that doesn't really exist in the Web2 world. Like, if you have $10 billion, can you perform an attack on a system to profit and then repay the $10 billion back? I think this is something that is very uniquely, and it's a very unique like crypto phenomenon that doesn't exist in Web2 world.
And that I think that's both an economic attack, but also highlights a technical vulnerability that we see a lot in smart contracts. We have to deal with the edges of numbers a lot more than you do in Web 2. So extremely large numbers and extremely relatively small numbers in the system can really mess with your math. It can mess with your logic. And with flash loans, like Hari's saying, like I can take maximum dollars, like the max storage space of that number in dollars and put it into your system. And as long as I return it, it's not going to cost me that much. So as long as I'm making money in that one transaction, I'm able to do that. How does your system deal with max uint number of dollars being pumped into it? Does that throw your economics or your technical system out of alignment? Are you envisioning those extreme circumstances? And I'll drop in here and make a recommendation for something that's much more on the technical side than we've been talking before. But there's a really great testing tool in the Foundry testing suite called fuzz invariant testing, where you're basically able to build a stateful test suite that also fuzzes numbers. So it will fuzz the inputs to your function calls as well as the order of those function calls. And that dual-sided randomness really will help you test your system in ways that you and your engineers aren't necessarily able to envision, because we think about how the system's supposed to be used. The machine doesn't know how it's supposed to use. It's just going to call things and see what happens. And if you have certain rules in your system that should never happen, you can really test those rules with the extreme boundaries of flash loans, or what happens if this address that shouldn't be calling this other address actually does call that other address. So I think the most secure systems that I have seen use invariant fuzz testing as one of their security layers, because those teams are the ones that are really security conscious and willing to invest the money in some very robust testing that can be difficult to set up.
This is like great practical advice, and I want to talk about two things. The first thing is it's very unusual and unusual for Web2 companies to invest a lot of resources into fuzzing, but it's so easy to build fuzzers in Solidity and in other, blockchain languages that you need to be, building these fuzz tests if you are writing software. It's extremely easy. It's as simple as like adding a new parameter to your test, which is not the case in some of the Web2 software. So if you are building software and coming from a Web2 background, you need to leverage these like very simple tools to write safer software. It's not that hard to do all those things. And the second thing I want to mention is I think this is very relevant to Chris because a lot of the original concepts for how to write a fuzz test, how to write, even like fuzzing itself, and even formal verification was pioneered by the Maker team. So a lot of tools that we are using today, the original idea on the interfaces, why it's important, they came from the Maker team. And they were like again the pioneers on many of these concepts that today are like commonplace. So I think like throw back to the Maker team and the people
Yeah,
that Chris worked with on developing these ideas.
yeah, that was definitely where
Um,
I first heard about formal verification and learned
exactly,
about how difficult it can be, but how powerful it can be.
exactly. I mean, this is
And now
such
it's much
a
easier than it was back then.
yes, yes,
Yeah.
exactly. So if you're building 100% leverage these new tools, they're very simple to use. It wasn't the case in the past. And it's not really the case in many adaptive software either. So writing a first test as simple as adding an extra parameter, so you can get something pretty good out of the
Mhm.
box. So going back to one more question in the chat. So I would like to hear your take on smart contract upgradability. I feel like it's a double-edged sword. We need a way to be able to patch bugs, but upgradability itself is a attack vector, which
Mhm.
can ultimately invalidate all other security assumptions if exploited. So I want to rephrase this for Chris, because Maker again is his Maker background is pretty relevant to it, because Maker is a $10 million protocol which often has to upgrade its protocol. So what do Maker do that you think is very relevant for anyone building software?
Yeah, I'm just going to jump from one soapbox of testing onto the next soapbox of upgradable smart contracts. I've gone kind of full circle on this one. When I was back in my first position at Consensus, upgradable smart contracts were kind of the hot thing, and everyone was figuring out the patterns for how to do them. I got very excited about them. I thought they were exactly the answer to this of how do we patch vulnerabilities, how do we add features, how can I get the software out the door faster? Well, I'll build a basic MVP and then I'll upgrade it later. That's a valid decision. You can certainly do that. I think it comes with greater trade-offs than most people making that decision realize, certainly than I realized at the time. Um, upgradable, the classic patterns of upgradability are fraught with memory management, um, private key management. If you have upgradability in your contracts, you implicitly have an address that can wholesale change your code. As this person points out, like it ultimately invalidates every security assumption. If that address gets hacked, they can put anything into your smart contract and have it do anything. Um, so that's, I think upgradability is an answer. I think it's one that is probably adopted a little bit too quickly, without a deep consideration of the concerns. So I'll get off that soapbox, Hari, and answer the question that you asked me, which is how did Maker design a system that was both upgradable and secure? Um, so the first thing is the addresses that have control in the Maker system, um, and my experience is much more with like Maker MCD era Maker system. So I don't know if these statements are still as absolutely true these days, though I suspect they are within the Sky ecosystem. Um, Governance, this one smart contract that could change parameters in the system, was only controllable by voters. So in theory, if the protocol engineering team went rogue and launched malicious actions for as a spell to change the system, we would still need to trick all of the majority of the voters to vote for that system. So having checks and balances around beyond just the security of the smart contracts was very, very important. Within the Maker MCD system, there is no upgradability. No smart contract can be swapped out from one implementation to another implementation, but we can add features to the system. We do that through uh, the word is escaping me right now, through modules. So the way MCD was built is there's this core smart contract called the VAT. That's the center of everything. That is the accounting system that runs DAI and the Borrowland system. It has certain contracts that it trusts to do things, or I'm sorry, it doesn't actually trust anyone. Certain contracts trust it. So it is an isolated system. And then contracts sit on the outside of that that trust it to do certain things within their code. Those contracts can be swapped out or added to. So rather than swapping out an implementation at a specific smart contract address, Maker adopted a more modular upgradable pattern where we would leave old contracts out there. I hope that it's Hari who's frozen and not me. Someone can give me a thumbs up if you can still hear me. That would be great. Thank you. Okay. I'll keep going and hopefully Hari joins us again. So Maker had that upgradable pattern of we're going to swap out modules rather than upgrade smart contract code in place. And so that allowed a type of upgradability that was, I think, a little bit more transparent and also instilled, again, going back to that security culture, instilled in the team and in the culture of Maker the idea that when we launch a smart contract, it is final and therefore it needs to be treated as though it's final. We can't just kind of quickly swap it out. One other thing I will point out, I read a really great blog post by an engineer at Base, Amy Corso, and there's a link on my Twitter feed from a little while ago to this. But basically, 7702, ERC 70702, which is now part of the Ethereum system, effectively makes every EOA an upgradable smart contract. I can change the implementation that my EOA uses. I understood that kind of at a high level, and it was Amy's blog post that made me really realize that also means all of the memory management and not overwriting memory slots and managing the sequential upgrades of your upgradable smart contract implementation also now applies to anytime you change the implementation that your EOA is delegating to. So I think that whether we like it or not, upgradable smart contracts are a part of the ecosystem. And that kind of methodology is something that we all have to deal with. And so knowing who can run the upgrades, having really great practices that are on chain, but more likely off chain, in how you select and verify the implementations that you're upgrading to. How does your community trust those? I looked at some code. I'll call someone out on the call. I hope that it's okay. But I looked at some code recently by John on here that was all about that. Is how do we publish something as a team that the community can then trust does what we say it should do? And that's a very good question when you're talking about decentralized systems and governance mechanisms or communities that you need to be able to trust their output, even if you don't trust all of the individual members.
Okay, this is all great advice, and I want to maybe cover some basics. The first thing about variable contracts, I think this is ultimately a business decision you have to make. As Chris said, um, we have seen certain certain teams do non-upgradable contracts pretty well, and one great example is Uniswap. I think they have almost every contract that they build is immutable. So once you deploy it, you know that it cannot change. And when they have different versions, there's a migration process. And this is sometimes a pain because now your users have to migrate liquidity from one contract to the other. But this is the decision that Uniswap has made. So once you put money in, you can almost entirely trust Uniswap to not steal your money because nobody can do any changes to the protocol. But we have seen, especially on the lending space, almost every contract is upgradable just because of the design space that they work with maybe one exception, which is the Morpho. They do have a very unique design where a lot of the core contracts are not upgradable, and you can deposit funds without worrying about can somebody just take my money away at whim. Okay, the second basic thing is try not to have like a EOA as your admin key that can break protocols. So I think that's like the easiest way for a malicious actor to compromise your system because in our experience, like an EOA or like an external account, which is like an account with a simple private key as the derivation, people tend to be more lax about it in general. People tend to have like a private key inside an environment file, and if your computer is compromised, which is a very real thing in crypto, this account is now compromised, and now a malicious actor can potentially upgrade your contract and steal all the money in it. So the basic thing is avoid an EOA as the admin for upgrades. Try your best to have at least a multisig, with enough number of distinct people as the signers, and enough threshold that you think is appropriate for your protocol. Something that we have seen people do successfully is if there is a lot of money on the line, you may want to have a faster way to do certain actions. And one particular action is pausing. So if you may want to have a system where you can upgrade, you can make changes, and what requires maybe a governance toward, maybe like a 4 out of 6 multi-sig toward. But there are a limited set of actions with well understood consequences that only one person can do. So one example is pausing. So perhaps you are in a system where there's billions of dollars on the line, and you find out about a bug that came through a bug bounty program, or you find it yourself internally. You often need to immediately pause the system while you figure out a way to resolve this issue. And in our experience, if you make the process of pausing really complicated and takes a long time, you may not be able to do this. So we have seen cases where protocols have this pause functionality, and that can often be done by a smaller set of people that doesn't need like the full upgrade power. So that's one way to like separate out how complicated it is to do an upgrade while still having good controls for very rapid decisions. Um, and whether I think upgradability is a bug or not, I think like I won't leave a particular comment there. I think it's ultimately like your choice. In certain applications, it makes sense. It comes with trade-offs both ways. Like I said with Uniswap, I think it's a very beautifully designed system, but every time there is an upgrade, which happens every 1 or 2 years, there is this liquidity migration, which is a bad, which tends to be like a bad like customer experience. You don't really want to move all your money from one to the other by spending money on gas as well. So with an upgradable system, this will be seamless, but it comes with more risk and decrease in trust in some way. Okay, we have 4 minutes left. It looks like we're getting a lot of interesting questions, more technical ones. One by Thomas. Do you recommend namespace storage for gradable contracts, or do you prefer to keep variables at lower slot indexes? Chris, what is your take?
Pick one and stick with it first and foremost. Don't mix and match. If you're inheriting contracts that have one pattern, maybe stick with that pattern rather than swapping it. I think the biggest opinion that I have around how to manage storage with upgradable smart contracts is to be very clear about what you're doing and be very consistent and be very well documented. Um, there's kind of this axiom of future developers won't know what you know now. And even if you are that developer, 3 6 months from now, you probably won't have the same context in your brain that you have right now. So always be kind to your future self and document things that are of critical importance, like storage slots. I think the trade-offs here are I like the namespace storage because I have a better, I believe that that gives me a better assurance that there's not going to be collision and there's a little bit less management, but that it makes your code more complex because accessing and storing information in those storage slots requires additional getter functions and helper functions and internal functions and all of that stuff. Um, I think there's an explicitness and a directness about the lower storage slot indices, but they require maybe a little bit more active, intentional management when you're making changes in the future. So I'm not sure which one. I don't think that I have a strong recommendation. I think that there are just trade-offs, and making a decision within your organization and then sticking with it to keep it consistent and keep it documented is probably the most important thing.
I fully agree on the documentation part, especially on upgradability, because we've seen a lot of cases where it's maybe like different set of developers that have to do the upgrade, which is very real, and they may not fully understand some of the assumptions that you made in the past. And another thing we would really recommend is try to simulate the upgrade yourself locally. There are great tools out there that can allow you to do it in a really good way. Like Foundry has a lot of great way to do local fork testing. So you can simulate an upgrade
Mhm.
and you don't have to worry about actually blowing up your system accidentally. So highly recommend simulating the full upgrade flow locally on a testnet or your local network before doing like a full production release. So no YOLO shipping, especially on the upgrades. Okay,
use
go on.
forks for that. And if you can get I think there was a company called Build a Bear that was doing like hosted test networks where you could deploy into their test network and then hook your DAP interface up to it and test against that deployment and really make sure that everything is okay and run through all of the integration tests, all of the user tests. You can do that locally. You can do that with a service, but having those tests, having those forks is very, very important. Like Hari said.
Yes. And if you're building today, like please leverage all those new tools that are out there.
Mhm.
Like Chris and like a lot of people, like they had to build this tool themselves. So a lot of them make a team build out these tools for their use case, but you don't have to do that work. You can just use a tool that's freely available from Foundry or products like I think Build-A-Bear, which allows you to have a very simple developer experience. So
Mhm.
I know that was a lot. We had even more topics to cover, but we're at time. And I want to thank Chris for coming to this event and sharing all this really practical knowledge that he gained building a $10 billion protocol. Uh, it's a very secure $10 billion protocol. It's just highly unusual in crypto. Like usually every protocol has a small security incident, and I cannot think of any like incidents in Ice Maker, and that speaks a lot to the quality and the security culture that the team had over the years.
Well, it was a good lesson for me to be able to join that culture when I did, and take those lessons into my later activities. And thanks for hosting this, Hari. I really appreciate it. Hopefully, you all got at least some words of wisdom and everything from my past experiences. Appreciate you tuning in.
Awesome. Thanks for coming. Thanks for coming, everyone. We'll see you next time. Bye bye.